All right, team. Here is the classwork for, actually, it'll probably be for a few days this week. Probably Monday and Tuesday, maybe a little bit of Wednesday. I'll keep you posted. Quick reminder, or FYI, I guess, winter break is December 21st through January 1st. So I know it sounds like it's far away, but it's really only a couple weeks. Okay. So what you need today and the next couple days, right here, you actually don't need your Eureka book. I don't know why I still have that on there, but you definitely need notebook, pen or pencil, and a calculator. Okay, so let's jump right into this. We're going to talk about representing data and describing the center of a distribution. And if none of those words seem familiar, don't worry. We're going to go over all of it. Okay, so if this was actually in class, I would ask everyone how many pets they have, and we would use that data. But since this is not in class, I just use a random number generator to generate these 19 numbers. So we're going to pretend that this is the data of how many pets each student has in our class. And yes, I do realize that 11 is a lot of pets, but you never know. Some people might have that many. Okay, so this is the data we're going to work with today, and a little bit of tomorrow. So let's first talk about this. We're going to organize the data before we even start graphing it. There's two different ways that I want you guys to get familiar with organizing data. In numerical order, and that's going to be especially important when we do box plots, where we need to find the median, and then also in a frequency table. So I did both of those already, just to kind of save some time on the video. So if you want to pause this and kind of look over it, basically numerical order, you're just going from least to greatest, right? So we're starting with the, no, let's not do that. Yep. Now we're lost. Okay. So I just took this data over here to make these two representations of the data. So numerical order, right? We just start with the least. So 0 and 0, right? 2 zeros, 3 ones, 3 twos, etc. So numerical order is just least to greatest. And then the frequency table, basically you're going to have whatever your variable is. That's not what I want to do. Zoom in a little bit. You'll have whatever your variable is. So in this case, we're looking at the number of pets people have, right? And then the other row in your table or column, depending on which way you set up your table, right, is going to be the frequency. What that means is how many times that value occurs in your data set. So for example, if we look at this numerical order representation of the data, we can see that there's 2 zeros. So in our frequency table, we would write a 2 for 0 number of pets. Right? There's 2 people who have 0 pets. Or in the next case, we have 3 people who have 1 pet, 3 people who have 2 pets, etc. So that's kind of how to read the frequency table and write the frequency table. Basically, it's just telling you how many times that value occurs in your data set. Okay, so those are the two ways that I want you guys to maybe pause the video and write those two representations of the data before we jump into the rest of this, just because we're going to be using both of those. Okay. Sorry, I have a little bit of a cold, so I might be a little sniffly. Okay. We're going to start with dot plots. We're actually going to go over dot plots, histograms, and box plots with this data. So, buckle up. Okay, dot plots. I know we kind of briefly talked about each of those representations, dot plots, histograms, and box plots a couple weeks ago, but it's been a while, so I'm going to refresh your memory on all of them. Basically, dot plots show it's a visual representation of the data, right? Just like any graph. What's nice about dot plots is that it's very clear what the frequency for each value is. Basically, what you do is have one dot, so one of these dots, each of these dots represents one person's data. Okay, so if this was our number of pets data, which it's not, but if it were, then that would mean that one person, only one person, because there's only one dot here, has one pet. Or in the 2 column, it would mean that 3 people have 2 pets, right? Or 5 people have 3 pets, etc. So you're going to place one dot for each data value above that number on a number line. And they each represent one data point. Okay. The other things that you're going to need with dot plots is title, what your variable is, the scale or number line, and a key. Now I'm going to go over what each of those would mean, but we're going to do this with our data. Okay, so I kind of already did like an outline of our dot plot, so to speak. So here's our data. Copied and pasted it over here so we can see it while we do the dot plot. So with our dot plot, the first thing you want to do is basically write a title for it. Now your title doesn't have to be like the exact name of your variable. For example, our variable is the number of pets students have, right? So your title could be the number of pets students have in Ms. Monson's second period class, right? So it could be something like that. It could be something a little less detailed, like how many pets do you have, or pets rock, or something like that. As long as it has something to do with the variable that we're looking at, so pets, number of pets, then the title is fine. So you need to come up with some kind of title for your data. And I do want you guys to make your own dot plots with me as I go through this. So if you want to come up with your own title and not use how many pets do you have, that's totally fine. The next thing you'd want to do is make your number line. This part right here, your number line or scale. To make your number line or scale, you don't have to start at 0, right? Maybe you have negative numbers, or maybe your first number is like 1,000, right? You wouldn't want to start at 0. So to choose what numbers are on your scale, I would just look at your data and see what the range of your data is. So for example, our data goes from 0 to 11, right? So that's why I chose 0 up to 11 here. Okay, so you have your number line, your scale. You need to write what your variable is. So the variable that we're actually looking at is the number of pets students have. So you could write it out that long, or you could just write a number of pets. It's just abbreviated. Either way is fine. Okay, let's see. Now we're just gonna, we'll just jump right into the data, and then I'll go over what the key means. Okay, so for each, let's do green, Christmas colors. Okay, so for each data value, meaning each number over here, each number will get one dot that we're going to place on our number line or scale. Okay, it doesn't necessarily have to be dots. You could use X's if that's easier, or stars, or whatever you want. Oh, sorry, big yawn. As long as you have some kind of visual representation for each data point. Okay, so let's do this. The first data point is 0, so we're going to put a little dot above 0. Second one is 0. So we have 2 zeros. And we have 3 ones, so we're going to put 3 dots over the number 1 on our number line. There's also 3 twos. So you can look at your numerical order, like each data point to do this. You could also look at your frequency table, right? So the next one on number 4, or sorry, we're on 3. On number 3, we have 1 dot, right? So you can look at either the frequency table or just the numerical order, or just your raw data, so like the unorganized data. Really, any of those representations will work for creating the dot plot. Okay, so number 3, focus. Number 3 is 1. One person has 4 pets. 2 people have 5 pets. 2 people have 6 pets. No one has 7 or 8 pets, so we'll just leave those blank. 9. One person has 9 pets. 2 people have 10 pets. Maybe they just have a lot of fish. That's fine. And 2 people have 11. Okay, so there's our dot plot. So each dot, again, would be the data from your data set. The next thing I wanted to talk about was the key. This part right there, this key right here. The key is just basically telling whoever's reading the graph what each thing represents, right? If you have stars, maybe instead, you would write 1 student, or you could write 1 student's response to the survey, right? It could be as detailed as you want, as long as we kind of get an idea of what each of those circles or dots or X's or stars represent, right? That's why we have the key, just so our readers can understand what is happening with our dot plot. So the goal kind of with creating these representations is so that anyone could look at it and basically be able to tell what we're talking about, right? So I could look at this dot plot and say, okay, we're talking about how many pets people have, right? And I would know that because of this information right here, I would know that, well, there's 2 dots above 0, so that means that 2 students have 0 pets, right? So the goal is to be as detailed as possible so that anyone could look at your graph and be able to tell what the information is showing us, okay? Okay, so that's basically it with dot plots. Those are pretty simple ones. So let's go back over here. Dot plots, I think I covered everything I wanted to. Yep, okay. We're going to move on to histograms now. And then if you have any questions on any of these, you can comment on this assignment or email me or do a private comment, whatever you want. I'm here to help. Okay. So histograms. These ones are probably my least favorite ones. But they're still pretty simple to create. Very similar to creating a dot plot. So you need basically the same things, right? We need a title, what variable we're looking at, the scale or number line. The only difference is that we have groupings, and I'm going to go over what that means. But here's an example of a histogram. Okay, so we have this data. What I mean by groupings is if you look at this scale or number line down here, it's not your typical number line where we go 0, 1, 2, 3, right? Kind of like we did before with the dot plot. It's grouped, right? Oh, that was bad. It's grouped, right? So it's not a single number. We have a group of numbers. Okay, so that's the difference between dot plots and histograms. We have groupings of numbers. And the hardest part is to decide what your group is going to be, right? So you need to group in a way that makes sense with your data. and I'm going to go over what it means, what I mean by don't let it disappear. Okay, so let's go look at our data to create our histogram. Okay, so if we check out our data, we know our range already is between, write this up, our range is between 0 and 11, right? So if you remember looking at that example I just showed you, the groupings were like 10 to 19, etc. So it's a lot of numbers. So if I were to split this up into, let's say, 0 to 5 and then 6 to 11, right? What would our histogram look like? Right? So if I had this right here was 0 to 5 and this right here was 6 to 11. Well, let's see how many people have 0 to 5 pets. So we have 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 people, right? And then on the other side, we've got 2, 3, 4, 5, 6, 7. Okay. But does that really give us an accurate picture of our data? So if we were to, for example, compare it to that dot plot we just created, right? We do see that, yes, more people have less pets, right? Just like our dot plot shows us, but it doesn't really give us a clear picture of how our data is distributed. So that's what I mean by you need to decide what your grouping is, and you need to group it based on what makes sense with your data, right? So if your data is super spread out, like you have a range of 0 to 100,000, right? You'd want your groupings to be bigger. But in this case, what's happening? Oh dear. Hang on. But in this case, we have a pretty small range of data, right? 0 to 11. So you can decide if you want, while doing your own histogram while you watch this and follow along, you can decide on a different grouping if you want to. What I'm going to do, just to kind of demonstrate maybe a good number of groupings for this one, is groups of two values. So what I mean by that is, maybe let's zoom in so we can kind of highlight what I'm going to be doing here. Go green. So by groupings of two values, I mean that 0 and 1 are going to be a grouping, 2 and 3, 4 and 5, 6 and 7, 8 and 9, and then 10 and 11. And again, you don't have to do it this way, but considering this data, it might be one of the better ways to do it. So let's take that information and start our histogram. So we already have our variable written out, the number of pets. We have our title, how many pets do you have? And now we need our scales. So frequency is going to be on this, I guess you could call it the y-axis, right? This guy right here. Just kind of like it was with our dot plot, right? If you look up here, frequency was on our, I guess you could call it the y-axis. So the highest number for our frequencies, if you look at our frequency table, the highest frequency was 3. Okay, so on the y-axis here, you could go just 0 to 3. I'm just gonna do 0 to 5, just because that's a good number there for graphs. So that would be a frequency of 5. That's a weird 5. That'd be 0. 1, 2, 3, 4. Oh, that was pretty evenly spaced. And again, you could just do a frequency on the side there of 0 to 3, and that's totally fine. All right, and then the groupings on the x-axis. Let's do this. So you're not going to write this part, the x-axis part, the groupings like a normal number line. So you wouldn't do like 1, 2, 3, 4, 5, 6, right? You could start with that if you wanted to, but it tends to confuse people a little bit. So what we're going to do is actually just break this up. So if we look over here, I wish I could like highlight with my mouse. Like highlight where my mouse is pointing without actually drawing. Okay, I'm getting distracted. If we look over there, let's count how many groupings we have. We have 1, 2, 3, 4, 5, 6. 6 groupings. Okay, so we need 6 little groups over here. So let's do one group. Actually, what I want to do this just because I don't have a ton of space here. So this is going to be 0 to 1, 2 to 3, 4 to 5, 6 to 7. You know what, maybe I'm just gonna, just so we can read this better, I want to make sure you guys are totally clear on how to do this. So I'm gonna rewrite the variable down here. Okay, that gives us a little more space here. So 0 to 1, 2 to 3, 4 to 5, 6 to 7, 8 to 9, and last one, 10 to 11. So that's still the number of pets people have. We're just grouping them. So what would we do for our frequency then? Well, there's actually a reason I went up to 5 on this, because if we look over at our first grouping over here, trying to highlight that. So we're looking at how many people have 0 or 1 pets. Well, if we add those numbers up, we have 2 people have 0 pets, and 3 people have 1 pet. So the total number of data points there I have is 5, right? So our column there, a little bar for our histogram, would actually go up to 5. So that means that, maybe I'll just write this in here so it's pretty clear what this means. 5 people have, normally you wouldn't fill it in, it'd just be a bar, 0 or 1 pets. Okay, so hopefully that's pretty clear, right? This is our first grouping, there's 5 of them. Our second grouping is the 2 to 3, so how many people have 2 or 3 pets? There we only have 1, 2, 3, 4. 4 people, so our bar there would go up to 4. So 4 people have, trying to make this as like detailed and clear as possible for you. Sorry, the handwriting is crazy. 2 or 3 pets. Hopefully this is making a bit more sense now. The next grouping is 4 and 5. There we only have 3 people who have 4 or 5 pets. 6 to 7, we only have 2. And let's see. 8 and 9, no one has 8 pets. Only one person has 9 pets, so it's going to be a total of 1 there. And then 10 and 11, there we have 4. So a weird number of people have a lot of pets. Okay, so there's our lovely histogram. So again, histograms, like dot plots, are good visual representations of frequency, right? We can look at this histogram and we know we're talking about the number of pets people have. And just based on having this information alone, like if we weren't actually shown the data, shown this stuff, or told anything else, we could look at this histogram and say, okay, whoever was surveyed here, 5 of the people who were surveyed have 0 or 1 pets, so 1 or less. We know that 4 people who were surveyed have 10 or 11 pets, right? So histograms, just like our dot plots, so if I zoom out a little bit, they're really good for showing frequency and kind of how spread out our data is, right? And because we grouped our histogram in groups of 2 values, so 0 to 1, 2 to 3, etc., it doesn't really change kind of the pattern here, right? We have a lot of people who have a smaller number of pets, and then a weird odd 4 people who have a lot of pets, right? So the pattern there is still the same from the histogram to the dot plot. So again, those 2 are really good for showing frequency and kind of how spread out the data is, or the pattern of the data. Okay, I think I covered everything I wanted to with histograms. Yes, I did. Let's talk about some specific vocabulary words that you guys need to know. And yes, you have been introduced to these before, so they probably ring a bell, but we're going to go over them again. I'll give you a moment to appreciate Ron Swanson here. I love Ron Swanson. Okay. Measures of central tendency. So you'll see that phrase more and more often the higher math you get with statistics. Measures of central tendency are basically talking about the mean and the median. So think of the words central, center. We know that mean means average and median means middle. So hopefully that wordplay kind of helps a little bit. Mean is the average, right? Mean is the average, median is the middle value. But how exactly do we find those? Let's talk about it. So I have posted the formulas here. So if you need to like pause the video and write this down, that'd be a great idea. These are very important things to know. So let's start with the formula for the mean or the average. Okay. There's a couple different symbols you might see that represent the mean. One of them is what we call X bar. X bar. It also just means the mean or the average. Another symbol you'll see is this weird like backwards Y combined with a U-shaped thing. That is the Greek symbol for the mean. Okay. Usually you'll just see the word mean. This will become more common this year and next year. And then if you take like a specifically statistics class, you'll definitely see that one. Okay, so those are the symbols that you'll see for the word mean or average. But how do we actually calculate the mean? Well, the mean is simply the sum of all the data points. Another symbol for sum you might see is this weird like E looking, like backwards. I guess it's not backwards. Kind of like a sideways M. But that symbol right there, that just means sum. So the sum of all the data points divided by, so that line means divided by the number of data points. And the number of data points, this phrase right here, is usually represented by the letter N. So if you ever see N, that just means the number of data points. So let's maybe go over to our data and calculate this mean. We'll go up to our box plot data or dot plot data because that's our most neat data set right now. I drew all over the other one. Okay, so the mean or X bar. The mean, again, is the sum of all the data divided by n, the number of data values we have. So let's do this. So I'm going to write this out step by step. Obviously, you don't need to write this out step by step every single time, but I want to make sure it's very clear how I'm getting this. So, sum of all of our data. We have 0 plus 0 plus 1. Basically, I'm just taking this information right here and writing an addition sign between each number. So this might take me a second, but it's okay because you should be doing this too, so it'll take you a second as well. Man, I'm writing this at a really weird angle. Okay, it's a little better. Let's see if I got it. Oh, no. Yep, okay. So we got all of that. So sum of all the data, we're going to add all of our data values up and divide by the number of data values. So if you count the number of values here, we have 19. We have 19. And yes, you do include the zeros. Okay, so we have 19, basically it's like 19 survey responses, right? Okay, so if we were to do all of that, actually I haven't calculated this ahead of time, so this is great. We can do this together. All right, so we have 0 plus 0 is just 0, so I'm going to leave the zeros out. But then we have 1 plus 1 plus 1, 1 plus 2 plus 2 plus 2 plus 3 plus 4. Guess I don't really need to read it out to you while I'm doing it. I know, it's super exciting. Okay. I think I got all of it. Yep. Okay, so we get 83. 83. That would be the sum of our data, so let's write that down so we don't forget. I'm going to do this in a different color to show where our answer is. So actually, I'll just write it. Nope. I'm going to write it up here. Maybe. Okay. Here we go. We're with it now. The sum of that data is 83. We know we have 19, so we're going to do 83 divided by 19. One of these days I'll get a better system. I can do calculator on top of it. Okay, so we're going to round to the nearest hundredth. Okay, so we have 4.37. 4.37. That was a really strange 4. Now, one thing I'm going to point out before we move on from the mean. I want you guys to think about if this number actually makes sense given what we're talking about. So what I mean by that is if I told you the mean is 4.37, what that is saying in context is that the average number of pets that people have is 4.37 pets. Now, can you actually have 0.37 of an animal? The answer to that is no, right? You can't have 4.37 of a pet. So what you would want to do in most situations, unless you're told otherwise, is to round it to what makes sense. So if you can actually have decimals of whatever your value is, that's fine. Do it to the nearest hundredth. But if we're talking about like animals or the number of people or things like that, you would want to round it to the nearest whole number. So in this case, we would say that the average number of pets students in our class have is 5. Okay. So there's the mean. Let's do the median now. I'm going to scoot it this way. Do purple. Okay. Median. Again, the formula for the median is n plus 1 divided by 2. So what that means is the number, remember that's the number of data values you have. And then you're going to add 1 divided by 2. Now again, this gives you position, not the actual median. Okay. This is very, very important. So let's go over what I mean by that. So we know that we have 19 data points. So let's write 19 plus 1 divided by 2. Well, that would be 20 divided by 2. That was weird. 20 divided by 2. That would give us 10. Now, the median is not actually 10. Okay, that's not the median. That's the position of the median value. So what we need to do now is find the value of the 10th data point. And yes, this needs to be in numerical order. Okay, so if we were to look at our numerical order here, you can just, I guess, cross things off as we go. 1, 2, 3, 4, 5, 6, 7, 9, 10. So 4 in this case, nope, I keep doing that same thing. So 4 in this case is going to be our median or our middle number. Okay, so there's mean and median for you, the average and the middle number. Okay, that information right there. Okay, now there are other important vocabulary terms that you guys need to know. Those are probably the most important right now, but let's go over other ones. And again, you can pause this, write it down. I would definitely suggest writing it down. So some words you may already be familiar with, for example, the mode. The mode is the most frequent value. So that means which one occurred the most. If we were to look at our data, we would see that the most common number or the most frequent number of pets would be 1 and 2. Right? 3 people have 1 pet and 3 people have 2 pets. So that'd be our mode, be 1 and 2. The minimum is just the lowest data value, so there would be 0. Right? We have 2 people who have 0 pets. The maximum, that's the greatest number. So in this case, 11. Right? There's 2 people who have 11 pets, and there's no one who has more than 11 pets. Actually, I'm going to write these down while we're going through. So minimum was 0, maximum was 11. The range is the difference between the highest and the lowest values. What that means is you're going to take your maximum value, so 11, and subtract your lowest value, 0. So that means our range would be 11. So that's kind of like how spread out our data is. Quartile, the word quartile. You might be able to figure it out just by the word quartile, quarter. Basically, a quartile is when we have a data set and we divide it into 4 equal groups. And these equal groups are basically 25% of the data each. And this will make a lot more sense when we do our box plot. So will these ones, but I am going to just read over them really quick. So lower quartile or quartile 1, Q1, is basically the median of the lower 50% of the data. Okay, so you would find the median, which would be exactly 50%, right? And then you would find the median of that lower 50%. And the upper quartile is basically the same thing, but for the upper 50% of the data. And again, this will make a lot more sense once we do our box plot. And then interquartile range is pretty self-explanatory based on that title, interquartile range. So range meaning the difference between two numbers. So with interquartile range, we're looking at the difference between our Q1 and Q3 numbers. So it basically tells us the range of the middle 50% of the data. Okay. Here we go. So let's move on to box plots, where some of this will actually make a lot more sense why we're talking about it. So box plots are nice in that they show more of the distribution of our data, but they do not show frequency. So maybe I'll write that down. They don't show frequency. What I mean by that is, if we were to look at this example of a box plot, which it doesn't really say what variables it's talking about or anything, but if we were to look at it, yes, we have a scale of numbers here, but let's say I were to look at the median here. Our median is 0 in this case, but it doesn't tell me how many data values were 0 in our data set. So it doesn't tell us frequency. There are a few common things that we do need, though: the title, what variable we're looking at, some kind of scale. And then the interesting things that box plots show us are listed here. So it does show us a distribution of the data, but in this case, it's in 4 equal groupings in our quartiles, right? What I mean by that is this part of the data right here, that's 25% of the data. This section is 25%, that's 25% of the data, and that's 25% of the data. So if you surveyed 8 people, for example, it would mean that there are 2 data points here, 2 data points here, 2 here, and 2 here. Right, splitting it up into equal fourths. Okay. Other things that they clearly show, box plots clearly show, are the minimum, maximum, the median, Q1, Q3, and the interquartile range. Again, this will make a lot more sense once we do it with our example. So let's do that. Box plots. Okay, so maybe take a second, pause the video, and catch up to the box plot. So I already have the title down, a scale down, and the number of pets. So the scale is basically the same thing we used on the dot plot. It's just a number line from 0 to 11. And then our variable is just the number of pets. Title that I have is how many pets do you have? Okay, so the important information we need for box plots to actually do our box plot is listed right here. Zoom out a little bit more. I don't know what just happened over there. Okay. Nope, one more. Too much. Okay, here we go. Box plots. Okay. So there are a few important pieces of information that you need in order to draw your box plot. You need the minimum, the maximum, median, Q1, and Q3. So let's again kind of go over those and calculate them together. All right, minimum would just be our lowest value. So if we look at our numerical order of the data set, again, this is super important that it's in numerical order. So if we look at that, the lowest value right there is 0. So our minimum is 0. So I'm going to put 0 over here. That's a weird 0. That was too. Oh. Okay, our maximum, that's your greatest value. So if we look at our raw data here, the biggest number is 11. So our maximum for this data set is 11. The median, again, is the middle value. And as we saw before, we know our n is 19. So we did 19 plus 1 divided by 2, which gave us 10. And again, that's the 10th position. So you need to look at the numerical order data set and find the 10th number, which in this case was 4. That's what we calculated before. So our median then would be 4. And that's the middle number. So if you were to actually, and this is a lot more common in the lower grades when talking about median, right? You'd get your little pencil and cross off one number at a time from each side, right? Do you remember that? Maybe you do, maybe you don't. You're like, no, I've always done it the smart way. And if so, awesome. Okay. I'm going to get rid of all those dashes I just beautifully drew for you. Okay. I just wanted to demonstrate that that was indeed the middle value. Okay. All right, next we need Q1. Oh, I did want to go over actually, if you have an even number of data points. So here we have 19 data values, but what if we had an even number? So what if we just, again, this is just hypothetical, but what if we threw in a 12 on the end of that data set? So I can't see where I'm at, I'm right here. 12, right? Well, then the middle value would actually be the average, the average of the middle two values. So if you were to find the median using the position formula, so 20 plus 1 divided by 2, 21 divided by 2, so it'd be 10 and a half, right? So basically what that means is you need to find the middle number between 4 and 5. So if that were the case, our median would be 4 and a half. Okay, I did want to go over an even number of data set values quick, and we will go over a lot more examples, but okay. Where were we? Oh yes, Q1. So Q1 or quartile 1 or lower quartile, you'll hear it be called any of those things, is basically the median of the lower 50%. So if the median is the middle value, it means it's the 50th percent line. Okay, so right here in our data set, that is 50%. So 50% of your data is over here, 50% is over here. Now we basically would just want to split those 50% into halves again. So we would end up with 4 groups of 25% of the data. Hence the word quartile. Okay, so essentially you do the exact same thing as when you found the median, only you're only using half the data. And you do not include the median, so you don't include this number 4 in there. So if we were to find the median then of the lower 50% of the data, so Q1, I'm going to kind of zoom in here real quick while we do this so you can see it better. So for the lower 50%, I'm looking at these numbers right here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 data values. So to find that Q1, we're going to use that median formula again. So if we have 9 values, we're going to add 1 divided by 2. And we're looking at the 5th value. So again, that number it spits out is not the actual median or Q1 or Q3, it's the position of that value. So we need to find the 5th number. So 1, 2, 3, 4, 5. So our Q1 or quartile 1 is going to be a value of 1. 1. Okay, now we're going to do the exact same thing just with the upper 50% of the data. And this will give us our Q3, quartile 3, or upper quartile. So here we're looking at this data. And again, it's going to be 9 data values because it's half of the data, right? And we're not including the median. So half of the data. And it gave us basically the same thing it gave us with Q1, where it gave us the 5th value. So we're just going to find the 5th value of the upper half of the data. So 1, 2, 3, 4, 5. So our Q3 then would be 9. Let's zoom out. Let's see everything in. Okay. So our Q3 was 9. Okay, and that's basically all the information you need to make your box plot. So what we're going to do to actually create our box plot, I'm going to zoom in a little bit up here. Okay. Essentially, you're going to put a line above your number line for each of these values. So we're going to have a line for 0, which is our minimum, a line for 11, which is our maximum. We're going to have a line for our median, which was 4, a line for Q1, which was 1, and a line for Q3, which was 9. And the middle 3 lines you're going to connect into a box. And then you just draw 2 lines going from the box to the minimum and maximum. And there you have your box plot. So once you actually have this data, which again will take you a lot less time than me going through it right now because I'm explaining it in pretty specific detail. It's a very fast thing to do, right? So I'm gonna label these just so it's very clear what's happening in our box plot. I'm gonna use red. So that's our minimum. That's our maximum. Here is our median, our middle value. Here is our Q1 and our Q3. So hopefully that made it a little more simple than maybe you've learned about box plots before. Another thing I wanted to point out with box plot is basically how to read them besides those specific values. What I mean by that is if we were to actually look at our data, let's use a different color. Pink. I'm going to zoom in a little bit here. Okay, so if we look at our box plot, you'll notice that it's separated into 4 groups, right? We have this group, we have this group, and this group. So those are our quartiles, right? Which is why we call this Q1, this Q3, and the median is actually called Q2. What it means, though, is that 25% of the people that we surveyed have between 0 and 1 pet. It also means that 25% of the people you surveyed have between 1 and 4 pets. 25% of the people you surveyed have between 4 and 9 pets. And then 25% of the people we surveyed have between 9 and 11 pets. So box plots are awesome in that they show us kind of the spread of the data, if you will, right? So the more spread out it is here, so notice how this is a lot longer than, say, this one, right? It means that this has, right, less, or I'll rephrase what I was going to say. I didn't actually start saying it, but the data right here we can see by the fact that it's a smaller section that more people have 0 to 1 pets, right? Rather than a higher number of pets, right? So more people have less pets, basically is what I was trying to say there in a very roundabout way. Okay. So there's our box plot. The only other piece of information which you guys will need to know is our interquartile range. Let me zoom out a little bit so we can talk about interquartile range, or IQR, as you'll see it abbreviated. Interquartile range, and I have written this before, I showed you it before, but I'll just rewrite it here, is basically the range of the middle 50% of the data. So if we were to look at our box plot up here, and I asked you, where's the middle 50%? Well, we know that 25 plus 25 is 50. So the actual box part of your box plot is going to be 50% of your data. So your interquartile range is basically saying what's the difference between your Q3 and your Q1. Okay. So let's do that together. So basically your IQR, to calculate it, you take your Q3 and you subtract your Q1. That equals your IQR. So in this case, our Q3 was 9, our Q1 was 1. So 9 minus 1 is 8. So the interquartile range, or the range of the middle 50% of the data, is 8. 8. Okay, I think that's it for box plots. Let me just zoom out and make sure we talked about all of that. Yes, we did. Leave it there for a second if you need to pause. Okay. Box plots. Okay. Let's talk about typical. Actually, let me see. I might want to break this video up into, yeah, let's break this up into different videos just because it'll take forever to upload. So since this is an hour long. So if you stuck with me for all of Monday's work through that, then you're set. So we'll call that Monday's work. And the next video I upload, we're basically going to talk about interpreting the data and the graphs that we drew. So we'll call that good for Monday, and Tuesday we'll start talking about the rest of it. So if you have any questions on calculating any of those terms that we talked about, or how do we draw dot plots, histograms, or box plots, or which one's best for what kind of data, please just comment on the assignment or email me. Okay, that's a lot of mess we made there, but it's awesome. Okay, so yeah, let me know if you have any questions.